Okay, students, now today we are going to start a super trick, which is most of the students demand regarding the organic. Okay, so they are not able to understand how to remember so many things in the organic. Today I'm going to give you a super duper trick, which is highly useful to find out two things in the aromatic compounds. What are those two things? First one is directive influence. First one is about the directive influence, and second one is about the electron withdrawing nature or donating nature or activating, deactivating group. Okay. So there are a lot of scope of this topic in the examination in every chapter. You can find the questions related to this in most of the chapters like carboxylic acid, cyanides, alcohol, phenol and ethers. Likewise, in every chapter, this topic comes. Okay. So before that, I wanted that every student should have a notebook, pen, and note down, keep a note of the very good points which I am discussing here, and try to watch till the end. When you feel it is a good video, please give a like, and when you feel that it is worthful, then share to your friends and promote my channel. Okay. And I think all of you are with me, and I will be coming. More you subscribe, more you share, more you like, the more encouragement I will get, and more good videos I will get, more tricks I am going to help give it to you, which is helpful to you for crack the entrance examination like NEET, mains, and many such examinations. Okay. So let us start with the topic, directive influence. Topic is directive influence. How to find out directive influence of a group in aromatic compounds with a super trick. The trick I am going to give you, but before that, where it is used, basics are required. So I am going to give you some important tips in between also. So don't skip the video, watch till the end and make a proper notes of it. Are you ready, students? Okay, now directive influence. Okay, so directive influence is studied in the topic of disubstituted benzene. In which topic? Disubstituted benzene. Okay, so suppose this is cyclohexane. Now it become benzene. Okay. So in the benzene, I will draw it for convenience like this. Okay. So already one group is present. What is present? One group is already present. Okay. Let us take this group 1. Okay. Now group 2 wanted. Another group 2 wanted to be accommodated. Okay. Another group 2 wanted to get accommodated on the benzene ring. Understood? So where it will be accommodated on this entire benzene ring, that is decided by this. Okay. The group 1 will decide where this group 2 is going to stay. At which place this group 2 is going to stay is decided by which one? Group 1. That means directive influence is a topic when a mono-substituted benzene is going to be converted into disubstituted benzene. Okay, so where you are going to use, is it understood, students? Now, so there are 3 places. You will find 5 places, but frankly speaking, there are only how many places? 3 places. Those active sites, they are called as active sites. There are only 3 types of active site. Quantity are 5. Okay, quantity 5, but number they are how many? Only 3. So this active site, after substituting this only, this active site is called as a ortho. Okay, this active site is called as meta. This active site is called as para. Okay, this active site is also called as, these two active sites are also called as meta. Okay, so this active site is called as ortho. Okay, so there are how many active sites? Ortho, 2 active site ortho, 2 active site meta, but there is only 1 active site para. Understood? So when a group is substituted, and these active sites are available only in substituted benzene. If there is no substitution here, there is no ortho, there is no meta, there is no para. So after mono substituted or after substitution taking place only, these 5 active sites are generated. Understood? And to remember this sequence, ortho, meta, para, you take the name of Lord Shiva. Okay, what is Lord Shiva? Om Parameshwara. Okay, Om Parameshwara. Technique to remember this sequence. Om Parameshwara. Okay, Om means ortho, M means meta, PAR means para. So ortho, meta, para. Otherwise, ortho, meta, para. This sequence, some students are forgetting in the tension of the exam. So when you are tensed, you take the name of the Lord Shiva, Om Parameshwara. He is going to help you and he is going to remember you. He is going to remember you that it is series is ortho meta para. Take my name, I am going to help you. Understood? So this is the sequence of the active site generated when a benzene ring is attached with some group. Okay. Now this group 2 will come to ortho or meta or para. That is decided by group 1. Okay. So whether it is group ortho, meta or para, that influence made by the group 1 on the group 2 is called as directive influence. What it is called as directive influence. Okay. Now I am going to tell you technique. There are two types of groups. Okay. Group 1 is divided into how many parts? Two parts. Ortho para directing and meta directing. Okay. So the depending on the directive influence. Okay. Group are directive influence. Directive influence of groups. Okay, directive influence of groups, depending on that they are divided into two types. Okay, OP directing. First one is what? OP directing. Okay, second one is M directing. Okay, M directing, OP directing and M directing, ortho para directing and meta directing. Okay, there are only two types of groups. Let it be hundreds of functional groups are there, hundreds of molecules are there, hundreds of ions are there. Either they should be OP directing or either they should be M directing. Okay, so, but which is OP directing, which is M directing, there is a lot of confusion among the student community and they are not able to mug up the things. And with me, you need not to mug up. Okay. If you follow my shortcut, immediately you need not to mug up. You give a functional group or you give a substance substitute, you will then immediately we are going to understand whether it is ortho para directing or meta directing. Okay. Are you ready with me, students? So short trick to find out OP directing or M directing. If you understand this, then future also going to be very comfortable in organic. Okay. So my intention is to organic made easy. Okay. There is a series going on with organic made easy. Most of the students are afraid of the chemistry because of the organic chemistry only, because they think that they have to learn most of the things, but it is not so. If you learn the concepts carefully and if it is made interesting, then organic is the best thing. It is going to be your favorite subject. Okay. So, but your learning method should be in that direction. Okay. So, directive influence, OP directing. A substance is said to be OP directing when it consists lone pair. Okay, simple technique. It should consist on lone pair on head element. Okay, what is that head element? I will give you example. Okay, this is only I am using the term and it is not some official. It is a simple technique. Either it should have lone pair or it should have hydrogen. Okay, on which element? On head element. What is that element? I will tell you. Okay, simple. Whenever you find lone pair, blindly you say that it is ortho para directing. Where? On the head element. What is that head element? I am going to give you. Technique 1 understood. If a head element contains lone pair or hydrogen, it is going to be ortho para directing. Okay. If the head element contains pi bond, which bond? Pi bond. Okay. Then it is going to be meta directing. And pi bond also on which one? Head element. On which element? Head element. Okay. On head element, if pi bond is there, simple two sentence technique. Pi bond meta directing, lone pair and hydrogen ortho para directing. That's it. You need not to mug up the things whether it is ortho para or meta like that. Okay. So let us see how it works. Okay. Now let us take first and most important one. Most important one. What is that? Phenol. Okay. Phenol. So here head element is the element or atom which is directly connected to, benzene ring. This is benzene ring and it is oxygen connected on it. Okay. Now there is a lone pair on it. Okay. So this OH group is which group? Lone pair and hydrogen if they are on the head element. Okay. Then it will be which group? Very nice. It is going to be called as OP directing. Which directing? OP directing. Let us take benzaldehyde. Okay. So in phenol, whenever the second group comes, you need to substitute at this place or you need to substitute at this place. It will not go at this place. Okay. Directive influence of OH group is OP directing. Okay. Now let us take benzaldehyde. Okay. So in the benzaldehyde, so this is the structure. Okay. So this is the head element. Okay. This is the head element. Now head element is having pi bond or not? So this is the pi bond. Okay. So when pi bond is there, that means it is which directing? M directing. Pi bond is there, it is M directing. Okay. Next, what is the next one? Benzoic acid. Okay. C double bond O OH. Okay. Again, it is pi bond is there, M directing. Okay. Now let us take the chlorine or halogen. Halogens. Okay. Halogens is having three lone pairs. So because of this lone pair, it is will be OP directing. It is going to be OP directing. Is it understood, students? In fraction of seconds, you are going to understand OP directing or M directing. Okay. So I will tell you what is the use of it. Okay. I will tell you how the questions will be there based upon this. Okay. This is benzaldehyde. Okay. Now, this is a question. Like this, hundreds of questions will be there. And how many you will remember? If you remember first reaction, question may be third. If you remember third, question may be second, like that. You need not to remember. Okay. So just now I told you this is a meta-directing group because of the pi bond present on the carbon and oxygen. Okay. Now this shows that substitute at this place. And this shows that what to substitute. Okay. And it is very famous. Sulfuric acid is a dehydrating agent. What agent? Dehydrating agent. Okay. So it want to remove water anyhow. So nitric acid, as a technique I tell you, you should write like this. HNO3 should be written as OH and NO2. Okay. And here it is plus, it is minus. Okay. And here this hydrogen, why this hydrogen? Because it is meta directing. Okay, this will be plus. So this will be eliminated. So this will be substituted here. Is it understood? So the answer is going to be no, need not to mug up. Okay, I'm dead against the mugging up the things. Okay, so the product, when you substitute here, the product is going to be what? At this place, aldehyde will be as it is only. Aldehyde will be as it is only. But here NO2 will be substituted. Do you use any typical things? No. Okay. Organic is very, very simple. If you made through the technique, if you study through the techniques, then it will be easy for you to understand. Understood? Now let us take one more example. Okay, good. Okay, next question is COOH and Cl2. So simple Cl2 is to be substituted. So at what place? At it is para directing. So Cl will be substituted here. Okay. So at meta place, what will be substituted here? At meta, chlorine will be substituted. Okay. No, for easiness, if I make it as a, in place of this, if I make it as a OH, okay, if I make it as a OH, then what it will do, chlorine will be substituted at ortho and chlorine will be substituted at para, okay. So chlorine and chlorine, this will be OH. Is it understood? Because now it is ortho para directing. Which is directing? Ortho para. Why it is ortho para? Because of the lone pair. So I think you felt good about the directive influence. Okay. I told you I will tell you there some more techniques at the last. The technique is ortho para directing. Okay. Are activating group. What group? Activating group. And M directing are deactivating group. Okay. So that means if you have two molecules, one is ortho para directing, another is meta directing, which will react fast, OP directing will react fast. Okay. So that is another technique. If you know the directive influence, they are also very, very important. Okay. So I think all of you understood and all of you like this technique. Simple technique, lone pair and alpha hydrogen. Alpha hydrogen example. Sorry, I forgot to give that example. Toluene. Okay. So Toluene is also, see here, this is the head element and all are hydrogens. Okay. So this head element if contains hydrogen, that's why it is OP directing. Okay. So if head element contains alpha hydrogens like this are lone pair, it is OP directing. And in last technique I told you OP directing groups improves the reactivity of benzene ring. That's why they are called as activating. Okay. And if there is a pi bond like here, if there is a pi bond, now it will become as M directing. Now it will become M directing. Pi bond, M directing, lone pair and alpha hydrogen, OP directing. OP directing groups are activating and M directing are deactivating. I hope you like this, and don't forget to like the video and don't forget to share a video to at least your two friends, and keep rocking, keep studying, keep watching which chem video channel for chemistry. Okay, bye.